All right, so they're really in the learning target with this one. I mean, it's kind of just understanding unit rates. So, I mean, I guess if you want to call it, it's really chapter 4. You know, understanding unit rates and what a unit rate means and defining unit rate. That's really what it is. So, a unit rate. Yeah, it's really chapter 4, but it's not learning target 4. It's chapter 4. So don't put a checker next is what I'm telling you. Okay. So a unit rate could be used in which of the following situations? Well, let's look to find missing measures in an equivalent ratio problem. Okay, so if I were trying to figure out like two out of 5, like 2 boys for every 5 girls, something like that. Let me flip that around. Use a better problem for you guys so you can see it a little bit better. Let's go 6 girls for every 2 boys. And I want to know, what if I have 50 boys, something like that? Could you find the unit rate of this and do, okay, I'm going to figure out how many girls that is per 1 boy, divide 2, and then just multiply 3 by 50. Could I do it that way?
Yeah.
So would you say that A would be, you could use unit rate to figure that out? Sure. Guys, all that is right there is learning target number 7. I can use unit rate to determine an unknown. That's what letter A is saying. So A is definitely true. Okay. Now let's go to B, because remember, we don't just stop there. We have to look through all the answers, find the 3 wrong answers, to determine when pairs of rate are equivalent. Okay. So let's say I have something that says I can buy for $30, I can get 3 shirts, or for $70, I can get 7 shirts. Could I use unit rate to see if those 2 things are equivalent?
Yes.
Sure I could. I could say, well, how much does that cost per shirt? Okay, that'd be $10, right? How much would it cost per shirt here? $10. Did I just use unit rate to determine when pairs of rates are equivalent? Now, a lot of people, I have a feeling, selected C because that is how we find better buy, right? Right? So, what's that mean then? All the above is the answer there. Okay, it is all of the above. I want you to put a star next to it because that question might come up again. Just saying. Do you have something to write with? Okay, let's go down here. Number 2. This is going to be learning target number 2 or number 5. Okay. Obviously, do you know what you're doing to go from 12 to 8? Do you guys know that?
Yeah.
What?
No, actually.
No, you don't. So, could you scale?
Yeah.
Sure, you could scale to 4 here if you wanted and divide 3. You could do it that way, but what's the method that I've taught you that's kind of that little trick? It is definitely a trick, but, Morgan? Cross, multiply, and divide. So we're going to do 9 times 8. We're going to multiply those numbers diagonally, and then we're going to divide by the other number. That's going to be divided by 12, which gives us 6. Okay? That's learning target number 5. Give yourself a check or an X, please, on learning target number 5.
Wait.
All right, this next one here. Okay. You had a ratio table that you had to complete. It says, Mallory takes basketball lessons from Mr. Edwards' daughter every summer. She took 24 lessons and paid $80. What is that, everybody? So as I'm doing this, you should be writing this too. Remember, your formative is your review guide now. I would try to do everything the way I did. Did you write that? I would be writing everything that I write because the summative is going to look just the same. Okay? So, you have to figure out, what if she would only have taken 18 lessons? Now, I hope you guys all realize that we could do it this way. Now, this would be wrong in this one. I would count it wrong. But could you solve it like that?
Yeah.
Couldn't you just cross, multiply, divide? But the directions in bold right here says you must use scaling, right? So we've got to figure out where we are going to scale. We're going to scale to this box right here. Now, what would be a good number to scale to there? What would be a good number to scale to? I just heard 4. Would 4 be a good number to scale to? No, because 24 divided by 6 is 4, but can 4 become 18?
No.
No, so what's another number that we could use here? 3 would be perfect. Okay, we could use that one. That would be a CF. That would be, hold on, let's just do this one first. That's not the only answer. There's multiple answers here. We could, what are we doing to go from 24 to 3? That's dividing by 8. So what are we going to do to the money? Divide by 8. There's $10. What are we doing to go from 3 to 18? Times 6. So we got to do times 6 there. We get $60. That's one possibility. Okay? So, and by the way, if I were you, I'd probably write different possibilities. Just saying. Okay, that's one. That's just one. That would be just a CF. What's another one that we could use? It would actually be the GCF. Kylie? 6. And if you're never sure, guys, remember, if you're not sure, if you're just terrible with your math facts and it's just not a strength of yours, go off to the side, do your trees for 24 and 18, and do it that way. You know what I mean? Like, that makes sense to me to do it that way. Like, why wouldn't you? But if you would do that, you would get a GCF of 6. What are you doing to go from 24 to 6? Divided by 4. So what do you got to do to 80? Divide 4. That's going to give us $20. So that means 6 lessons cost $20. And then what are you doing to go to 6 to 18?
Times 3.
So what do you got to do here?
Times 3.
Did we get the same answer regardless?
Yes.
Is there another option we could scale to?
Yes.
Morgan?
2.
2 would be working too. That would work as well. That's another CF. So if we did 2, we'd be dividing by 12. The only issue here is you would get a decimal. That's okay. Money can go to decimals. That's no problem. Okay, that's okay. I would advise you to try and use the GCF when necessary, or when you can. It'll help you. Did anybody use the LCM? Yeah. Okay, if you would have done the LCM, you would have gotten 72 here, which would be times 3 times 3. And then divided by, what would that be? 4. Divide 4, you'd still get 60. You guys see that? So there's multiple opportunities there to use whatever. Okay? Cool? All right. That was learning target number 1. Give yourself a check or an X for learning target number 1.
So if you did, like, if you got 60.
If you got 60, listen, you had to scale, though. You had to do one of the 3. It's worth 1 point. Everybody got that? It's either right or wrong. Yeah.
What learning target was the question 1?
There wasn't one. Okay. Here we go. This question, you're going to see all the, I mean, really, I keep saying, I'm going to keep putting stars next to these, but really, every question on this formative, there's going to be one like this on the summative. Okay? So, here, I gave you the fake ratio. This is Mrs. Allen's greatest veggie salad ever created. Her recipe serves 30 people, and it calls for 40 cups of broccoli, 30 cups of Brussels sprouts, 60 cups of asparagus. Okay? Right? Try that. If you change this number, if I all of a sudden make this 50 cups of asparagus, is it going to taste the same as it would have before? No. That's why recipes are in place. And if you want to double your recipe, then you must double all your ingredients, right? If you multiply your recipe by 3, that means you need to multiply all your ingredients by 3. So A says we want to know how much we would use, how much of each ingredient will we use to serve 15 people. So what I did for you, if you didn't notice, is didn't I basically scale it for you? Right?
Yeah.
So I basically created this so that you could easily say, oh, okay, what am I doing to go from 30 people to 15 people, Kylie? Dividing it by 2. So if I'm dividing my number of people by 2, I don't need to make it for 30 people. If I'm dividing my people by 2, what do I need to do to all my ingredients? So that's what we're going to do to all of our ingredients, right, guys? So that means 20 cups of broccoli. That means 15 cups of Brussels sprouts. That means 30 cups of asparagus. Got it? What are we doing then to go from 15 to 45? Times 3. So then we do that to all of our ingredients. 20 times 3 is 60. 15 times 3 is 45. 30 times 3 is 90. Does everybody see how we did that? Very simple, actually. That is learning target number 1. Got it? Make sure you're actually marking. It's not really, we're not going to calculate your grade. I already have your grades from Schoology. So it's really not about you getting a certain grade. It's just more about you realizing what you missed and how you're going to correct it for the summative. All right, next question down here. I got to go all the way down. Number 5. Okay, this is going to be learning target This one's going to be, this is going to be learning target 6. This one down here is going to be learning target number 5. These up here really aren't learning. Again, that's more chapter 4 stuff. It's just kind of review. So let's read through here. I'm going to do all 4 of these. Okay. In the computer lab, there are tables and chairs. The ratio of tables to total is 4 to 9. What should everybody have done at this point right now on your paper, Jaden? Edge pieces. That's what I would want you to do. If you didn't, let's do it now. Let's go ahead and do it now. So what does that mean? Give me one edge piece that I get from that particular fake ratio. Morgan?
4 tables.
4 tables. Give me another edge piece. Vienna? That there are 5 chairs. Now we'll talk about how I got that. That's the one you got to work for a little bit, right? There's always one that's a little harder to figure out. And what's the final edge piece?
4 in total 9.
9 total. Right, everybody? That's just the fake ratios, the fake information, whatever you want to call it. This is all fake stuff right there. Fake. It's fake. Okay? If you're wondering how we got 5 chairs, I'll go through it real quick. If you got a room right here, and I got all this furniture in here, I got furniture, furniture, furniture. I got 9 pieces of it, right? Right, everybody? I know that 4 of them are tables, so I would make 4 of them T's. How many are remaining?
5.
Then that means those 5 must be the chairs because there's only tables and chairs in that room. Does that make sense? That's pretty basic because we've done that enough, but I just wanted to go over that and make sure we understand. Really, it's about reading, guys. This same question could almost be in your English class, be a reading question. It's really more about reading than it is about math. Okay? So, here we go. What is the ratio of tables to chairs? Okay, well, if they give me tables first, then I got to go over and look and say, okay, tables comes first, chairs comes second. For anybody that may have missed these, then you're either rushing or you just misread it. Okay, now let's look for the number of chairs to total right there. Go to your edge pieces. That's going to be 5 to 9. Everybody seeing this? What? Yes. Okay, now we're on letter C. Those aren't learning targets. Those are chapter 4. Not learning target 4, chapter 4. I'm just saying that's review. That's writing a ratio, right? That's turning a part to part into a part to whole, right?
Yes.
Okay, actually turning a part to whole into a part to part. Now, for C and D, what work would I require? Let's go through those steps. Maybe I should write the steps. Maybe you all should too. I'm going to write the steps for these types of questions. What's the first step you have to do, right?
Proportion.
A proportion. There's step number 1. You may want to write this. Step number 2. What's step number 2? Reagan?
Labels.
Labels. What's step number 3? Anybody know step number 3? Yep.
Fake ratio.
Fake ratio. You put your fake ratio on there. And then step 4 is what?
Real information.
That's where you put whatever the real is. Whatever they gave you, the real. The real information is always found after the word if, usually, correct? I shouldn't say always, but most of the time it is. So, let's do that now. So here's my proportion. There's step 1. Check. Now, how do I know which labels to choose? Am I going to be doing chairs to total? Am I going to be doing tables to chairs? Am I going to be doing chairs to total, tables to total? What am I going to do? That is what we've got to figure out. When I write labels, that's really when we look at the question, and that's how we figure it out, what we're going to put on there, right? So, the question states, if there are 30 chairs. Now, when you guys read that, a lot of you instantly go over and put this like that. Don't do that, please. Let's do it the process, do it the way I've given you I just want you guys to be successful, that's it. And I'm trying to give you the tools to be successful. Look for labels only. I see chairs, then I know that chairs has to be one of my labels. Now it's going to ask me for something. What is it asking for?
How many pieces total?
Total. Now be careful just writing T. Why?
Because
table starts with T also. So when I get like tables like this, I like to put TOT. So TOT. Now I'm done with step number 2. Let's go to step number 3. That is where we build this from our Edge pieces. So what is the ratio of chairs to total? Yes? 5 to 9.
Could you do the opposite way?
You could, but I'm just trying to give you guys a method of doing it. Guys, ratios can be flip-flopped always. Like as far as in a proportion, you could put the real first. But I just try to give you guys the skills and strategies. I try to keep it consistent, right? And I think that helps most of you. So you didn't have to do it this way, but you had to do a proportion with labels. Okay? So what piece of real information did they give us? They gave us that there were 30 chairs. Give me one way that I could solve this proportion now. Kylie? I could do 30 times 9, which is 270, and then divide by 5. That would be 54. That's one way to do it. Or what's the other way that you could have done it?
Figure out what you're multiplying.
You could just figure out what you're multiplying by. So we could see times 6 times 6. Either way, we're going to get the right answer. But I really want to stress to you guys, cross multiply and divide. Doing that method right there it'll never give you any issues. The other method will sometimes. Like if this number right here was 31, right? Then you would have to do cross multiply divide. Does that make sense? Okay. Now let's go down and do the other proportion down here. So here we go. I'll just do it over these lines. Let's read letter D. If there are 36 tables, so what's one label that's going to go on here? So maybe you put TA for tables. Okay. And then it asks for how many? Chairs. By the way, does it matter whether tables or chairs is on top or bottom there? No, part to part doesn't matter, right? Part to part doesn't matter. If I did boys to girls, if I said it was 4 boys to 5 girls, is that the same thing as saying 5 girls to 4 boys? Same exact thing, right? So this is no different. But when you have a proportion with total, should total always go into the bottom? Yes. Okay, so what's my fake ratio of tables to chairs? 4 to 5. What piece of real information did they give us? 36. You could cross multiply divide here, or you could see we are multiplying by 9. Multiplying by 9, that's going to be 45. Everybody got that? 45 chairs. Learning target, that was the number C. Letter C was learning target number 6. Letter D was learning target number 5. All right, number 6. Definitions questions. It's going to be on the test, but I think we've made that clear. Okay. A ratio expressed as a quantity of 1. That's number 1. 2 equivalent ratios, or a comparison of 2 numbers with different units. Okay. So what are we doing here? What do you guys think? What is a ratio expressed as a quantity of 1? Yep.
A unit rate?
That is going to be a unit rate. That is going to be letter C. Okay. Anytime you see that word, what does the word unit mean, guys? That's all right. That the word unit means 1. So when you see something being expressed as a quantity of 1, yeah, that means unit rate then. Pretty simple. All right. 2 equivalent ratios. What do we call that? If I said that 2 boys to 5 girls is the same as 4 boys to 10 girls. That is a proportion, right, guys? That is a proportion. That's exactly what it's saying. That is letter E. Yes? It doesn't matter. It might have jumbled them up. That's okay. Just make sure you get the right word to the right letter, or to the right definition. And then finally, one that maybe got you guys here, one that maybe I didn't stress enough, but understand that it will. What do you guys think it is?
I think rate.
Rate.
Ratio.
Comparison of 2 numbers. I'm going to accept rate or ratio on that one. I'm going to accept either one because, yeah, it was rate. That is what a rate is. So, but I'm going to accept that one. Okay. Those will be on the summative, so you should be prepared for them. Nobody should miss them on the summative. Okay, question number 7. This is going to be learning target number 5. 5, okay, if Tate Middleton makes 5 out of every 27 layups attempted, okay, so is that my fake information right there, guys? Now it's going to give me the real. Here we go. Here's the question. How many layups would he make if he attempted 72? So this is obviously has to be done with a proportion. Our fake ratio says that he's making 5 out of 24 total, right? You didn't have to put layups or anything like that. When you shoot a shot, when you shoot a layup or a shot of any kind, there's only 2 things that can happen. What are those 2 things? You either make it or you miss it. So we are talking about makes to total shots. That's all it is. If you put layups, that's fine. I don't care. So we know we're talking about makes to total. And then what piece of real information did they give us?
72.
Now, is that representing the amount that he made or the amount he took total? That's the amount he attempted. We're going to cross multiply divide here. Or you could just simply say, okay, I'm multiplying by 3, so I've got to multiply by 3 here. That's going to be 15. 15 made layups. Everybody got that? Learning target number 5 right there. Okay. All right, number 8. Now I will take a couple seconds on this one because this one is going to be wrong if you didn't do something, so pay attention. Now I'm going to tell you right now the correct answer is, I think 54. Is that right? Okay, that is the correct answer. Now, I'm going to show you, this is learning target number 7, by the way. This is the one that I warned you about. This is, I can use unit rate to find an unknown. Okay?
Wait, the second box, the one that
The whole thing.
Snow thing.
It's the whole thing. This is 54. Up here, the unit rate, we'll find, that's 6 to 1. Okay, now, couple things, first of all, that I know you guys were thinking. Put your hand down. Just wait. Okay, obviously, I just want to show you this. If you did this, it is wrong, but I want to show you. If we wanted to solve this one, just like we did on the Tate Middleton question, the one before this, we could set up a proportion. We could do, okay, we would say, okay, my fake ratio is 48 inches for every 8 hours, and I want to know how much it's going to snow in 9 hours. Could we solve this by cross-multiplying and dividing?
Yes.
Yes, and it would give you 54. That is absolutely true. If you did that, it is wrong, though, because this target specifically says you must use unit rate. So, because you had to use unit rate, you had to have 2 different proportions. Everybody understand that? So, I'm going to do my first proportion. If I had to find unit rate, that means that I had to find the amount of something per one of something else. Okay, so now here's the big key. Do we need to figure out the amount of inches per hour or the amount of hours per inch? Yes.
Per hour.
And the reason we do that is because they gave us hours. You find per one of whatever they gave you, the real information. So we know this is going to be hours. We know this is going to be inches. Inches, if you didn't have this, I hope you're writing it once again. This is going to be 48 inches in 8 hours. We are dividing our number of hours by 8. By the way, could we cross multiply and divide here also? Yes, we could. Divide by 8. We learned that it is 6 inches in an hour. Now, some of you were confused because this said hours. Now, we just obviously when Mr. Edwards made this the other day, we were making it together and I didn't catch it. He either did it on accident, which I think probably did happen. He just put hours, didn't think. And then, or maybe he didn't want to put hour because it kind of gives it away. You know what I mean? If he puts hour, you kind of know it's 1. See what I'm saying?
Yeah.
So he might have done that. So don't let that trick you. Unit rate is the amount of 1. The amount of something per one of something else, right? So, it will snow how many inches in 9 hours? So now, do you need a second proportion?
Yes.
Yes, you did. Now you had to use your unit rate as your fake ratio. And we need to now fill it out like that. Does everybody understand what I got going on here? I did one proportion. What?
I was gonna ask, I didn't do a second proportion. I did just 6 times.
No, I made it very clear I want 2 proportions on this. So write yourself a note. So now we're going to do times 9 times 9. We're going to get 54 inches. We got the same answers we did before, but because it says the directions right there, use and show a unit rate, that showed you had to do that. So your fake ratio turned into a unit rate. Your unit rate turned into the fake ratio to find the real information. Does everybody understand that? Okay, let's keep going here. I know we're getting this has been kind of long, but it's important to go through these. All right, here we go. Unit rate. I had so many people asking me throughout the day, do I round? Guys, we always round money. There's no such thing as $3 and $3.2. There's no such thing. It has to be made into $3.20. You guys just got to look at it. When you get something like this, like we had that one on the other day on that worksheet, you have to think, okay, that's 219. But is the one to the right of it close enough to make it 220? Yeah, so that would be 220. Okay? So, going back to this. We have unit price. Now, who can explain to me what unit price is again? Yes?
It's a proportion, but the money's on the top.
It's a unit price it will become you use a proportion to find it. Unit price is the amount of money per one of the object, right? Okay, so obviously, how many proportions did you have to have here?
Two.
Had to have 2 proportions. What always goes on top in money? Always on top. You can write that if you want to. It's always on the top when you're doing unit price. You're not interested in writing it? Okay, just checking, because I'd probably be writing everything if I were you. Okay, this is going to be suckers. I'll put SU, suckers. My fake ratio is that it's $4.20 for 16 of them. I need to know how much one of them is, because that's unit price, right? So I'm dividing by 16, dividing by 16. When you do that, what do you get? Yep. 26 cents. What do you get? Like, do you get exactly 0.26? Yeah, what do you get? I want to know what you get. Does anybody have that?
It's like 0.55.
Here, how about this? I'll just type it in.
0.2.
Let's just do it so we can all look at it. So it's 4.20 divided by 16. Oh, shoot. There we go. Okay, so 0.625, 2625. So we look at that and we go, okay, this right here is my money, right? That's money. So this is either going to be 26 cents or it's going to be 27 cents. We're going to look to the thousands to answer that question. Is that number to the right 5 or more? No. So this is going to be 26 cents. So that is our unit price, 26 cents. Okay? Now we'll do our other proportion. Here we go. Same way, we're going to have one here, and we're going to put money on top. Money on top. This time we're talking about Snickers. We know that we can get 12 of them for $5. Whoops. I put those in the wrong spot. See what happens when you mess up your labels? Yep. Okay, so that's going to be $5.08 for 12 Snickers. Divide 12, divide 12. We'll bring this guy back here. This is going to be 5.08 divided by 12. Okay, now my highlighting, or my line's in a bad spot. There we go. So now we know this is going to be, draw your line right there. This is either going to be 0.42 cents or it's going to be 43 cents. What's it going to be? That 3 is not large enough to get it up to that, so it's going to be 42 cents. So there we go. Everybody understand that? Unit price. That is learning target number 8. Learning target number 8. Yes?
So what if you got 2 right and then 1 wrong?
We're not grading it right now. You just need to know what you missed. Okay. Well, if you then put 2 X's. Oh, I'm sorry. We got to do that last one, don't we? Okay. Now, so we said this was 26 cents. We said this one was 42 cents, right? All right. So if we know that it's 26 cents, everybody watch this. People were so confused on this one when we did it in class the other day. Watch, please. I'm going to do it with proportions. Watch. I'm doing letter B. If I know that it's 26 cents per sucker, that's my fake ratio now, right? And I know I want to buy 5 of those suckers. I'm going to be multiplying it by 5 by 5. See how I use proportions? Okay. What is that going to give me? $1. It's 1.3, which we know is $1.30. You must add that on there. I will count it wrong on the summative. Okay? We'll do it for the other one now. We know that it was 42 cents for 1 Snickers. We need to know how much it's going to cost for 7 Snickers. Times 7 gives us? $2.94. Now, what am I finally going to have to do here? I'm going to have to add the cost for 7 Snickers, the cost for that, and we are going to get $4 and... Guys, did everybody see how I use proportions there?
Yep.
8.
2, number 8.
Yep. Actually, 3 there. What? Yeah. No, I would do 3 different checks or X's there. Okay, bar modeling. This is going to be learning target number 4. Learning target number 4. We've seen this Harry and Lincoln question about 1,000 times now, right? Okay. The ratio of Harry's money spent to Lincoln's money spent is 6 to 5. Now, what I like to do right now, even though we didn't have to do this, I like to do edge pieces, right? And I like to say, okay, that means 6 for Harry, that means 5 for Lincoln, which means 11 total. Which makes the model make sense because you have 6 boxes for Harry, 5 boxes for Lincoln, which means there are 11 total boxes. Everybody understand that? Okay, let's go through and figure out what these guys are wanting to do now. Harry and Lincoln purchased several tickets to the Cavs game Friday night. They paid a total of $715 for all their tickets. How much did Harry pay for his tickets? So, what we really have got to figure out with this bar model is we've got to, JT, come on. We've got to figure out how much. Remember, I said bar modeling is all about figuring out how much is in one little square. If we can figure out one square, that's the key to the entire thing. How am I going to figure out how much money would be represented in each one of these squares? How much money? Jaden?
I might have done it a different way, but I did 715 divided by 11.
You did by 11. Now, the reason he did divided by 11 is because this is how much they have total. If it was Harry has $715, you would do 715 divided by 6, right? If it was Lincoln that had $715, you would do 715 divided by 5. This is the total they spent, so you do it by 11. When you do that, what do you get? You get $65. Now, what does that mean to you guys? Well, that means that each one of these boxes is $65. Every single one of them. They're all the same value. That's what bar models are all about. Love them or hate them, and I know some of you love them, some of you hate them. Okay, I didn't learn this way. I had to reteach myself bar models. I never learned this. But that's the whole thing about it, is trying to figure out how much one square is. It's kind of like unit rate, right? Figure out how much one square is, and then go from there. Now let's answer the question. How much did Harry pay? Well, if Harry's got $65 in each box, and he has 6 boxes, wouldn't we just do 65 times 6? And wouldn't that give us $390? Okay, and there's your answer. Now, if you got done, what could you have done to just check your work here? What's something you could have done that you guys are pretty good at this point? JT?
What's 715 divided by 300? I mean, minus 300.
No. Could you have set up a proportion? Yeah, they gave you a total, and they asked for Harry, right? So wouldn't it be Harry to total? What's my fake ratio of Harry to total? 6 to 11. What piece of real information did they give us? We could have crossed, multiplied, and divided, and we would get 390. Just a little check method. I would maybe write that, check with a proportion, because you guys are good with it. Proud of you. Good job. All right. Let's go on. I already had it up there. Okay, better buy question. Okay, better buy. This is learn target number 8. You guys pretty good at these. I was pretty pleased with this. So, a 24-ounce box of Captain Crunch at Target costs $9.60. So what I'm going to do is I'm going to do Target here. So I'm going to get this set up. We know we're going to do unit price, right, everybody? Because it says which is offering the better deal per ounce. So it kind of makes you put money on top, ounces on the bottom, right? So we're going to do money on top. We're going to do ounces on the bottom. Right, everybody? Yeah. Then we are going to do $9.60 here for a 24-ounce box. We need to figure out how much that is per ounce. That's Target. Now I'm going to go down here, and I'm going to do Kroger in this color down here. And we still are doing money to money, ounces to ounces. Okay? Now we look and we say, okay, a 30-ounce box is $12. So we're going to put $12 there and 30 ounces, and then we want to figure out 1 ounce. Right? Right, everybody? Okay, so let's do the math on this. I'll get out my calculator so you can just look at mine. Okay, so we know that down here we are doing divided by 30, 12 divided by 30 there. So we are going to go 12 divided by 30, and that is going to give us 0.4. Now, you guys all know that 0.4, is that an actual amount of money?
No.
No, it's not. What is $0.4?
40 cents.
40 cents. Hey, be with me, please. 40 cents. Okay? Let's go up to Target now. Do the same thing. We know we're dividing by 24, dividing by 24. Okay? We'll clear this out. We'll do 9.60 divided by 24. Okay? Oh, we get 0.4. Which means 0.40, correct? Okay. So we're looking now. What do you guys? What statement can you make right away? What statement could you make without even looking at the answer choices right now? Yeah.
Most stores are selling it at 40 cents an ounce.
So
They're selling the cereal at 40 cents an ounce.
exactly. So when we look at this, who's offering the better deal? Both of them are, right? Now some may make the argument and say, well, wait a minute, you're still getting more here, but you're also spending more. But when we're getting to a better buy question, we're trying to figure out what is cheaper per ounce, per the item, whatever it is. And in this one, the only one that makes sense here is they are both offering the same deal for 40 cents a piece. Yes? Okay. I would just write yourself a note that you make sure you know it. Okay? Everybody understand that? All right. Down here, question number 12. Okay, question number 12. It was learning target 8. I said that. You guys should hear me say it when I put it up there. This is learning target number 9 here, guys. Everybody hear me? Learning target 9. Okay. There are 5 questions here. How many proportions do you need?
9.
You needed 5. If you didn't do 5, mark it wrong right now. Hear me? If you didn't do 5 proportions, mark it wrong. If you don't do proportions on the summative, it will be wrong. Understood?
Yes.
So A. What's the first thing go on my proportion, guys?
Fake ratio.
No.
Label.
Label. So we're doing feet to inches, correct? My fake ratio is down here. That 1 foot is 12 inches. What real information did they give me? Times 6 would give me 72. Okay, let's do letter B up here. We are doing quarts to cups. Quarts to cups. Okay, my fake ratio for quarts to cups is that 1 quart is 4 cups, right? Right? Okay, so we know that 7 quarts times 7 would be 28 cups. Let's do letter C. Okay, I'm doing ounces to pounds. Ounces to pounds. There are 16 ounces in 1 pound. I want to know for 48 ounces. If you're not sure that this is multiplying by 3, could you cross multiply divide? Yes, you could. You would get 3 pounds. Okay, we'll do the other one over here. Here we have kilometers to meters. Kilometers to meters. See how the proportion takes the thinking out of it, guys. So easy. Okay, I see it right here. 1 kilometer is 1,000 meters. Okay, they give me 56 kilometers. Times 56 times 56. It's going to be 56,000. And finally, letter E is right here. We're doing meters to centimeters. Meters to centimeters. I see that the fake ratio is that, yeah, that's right. 1 meter is 100 centimeters. They gave me 45 meters. Times 45 times 45 would be 4,500. 4,500, not 45,000 there.
Using a lot of green and purple.
Okay? Everybody got that? Give yourself 5 checks or 5 X's on that one. Question number 13 now. Here we go. Yes. Right, just give yourself 5 X's if you didn't show the proportions, because it will be wrong on the summative. I hope everybody heard me. If you do not do proportions for that learning target 9, for that section on the summative, it will be wrong. Now this one, this is really learning target number 2. It's only learning target 2 we had on here, I think. Okay, but right here, we are looking And what I'm going to do is I'm going to add an extra box. You guys can do this if you want to right now. I'm going to add an extra row. And the reason I'm going to do that is because, isn't this a fake ratio right here?
Yeah.
So couldn't I put that in there, 10 for $40?
Yeah.
Okay. Now it's just a table. It's learning target 1 almost, really. You know what I mean? So what would I be doing to my number of tickets to go from 10 tickets to 1 ticket? So what do I got to do to $40 to get up here to figure out how much 1 ticket costs? Divide by 10. So don't you agree that each ticket is $4?
Yep.
So what am I doing to go from 1 ticket to 2 ticket? So wouldn't that be $8? What am I doing to go from 2 tickets to 4 tickets? So wouldn't that be times 2 there? 16. So people were confused. Well, wait a minute. What do I put right here then? Well, it's pretty easy. This is your X. This is your Y. Right? So this would be 1 comma 4. 2 comma 8. 4 comma 16. I hope you're all writing this, getting this down. That's it. Now, for letter B, also learning target number 2, if you were to plot these points on a coordinate plane, it would show a constant, guys. Everybody write it right now really big. Guys, whenever you have a ratio table, whenever you have the same ratios, do you agree that 1 to 4 is the same as 2 to 8?
Yes.
Which is the same as 4 to 16, right? Which is the same as 10 to 40. Aren't those all the equal ratios?
Yes.
They're all equivalent. Whenever you have equivalent ratios, you will always have a constant rate of change because it's going up. Think about if you were to graph this, guys. Think about, hold on, just watch for a second. Something like this. So this would be 1, 2, 3, 4, 5, 6, 7. Wouldn't this be over 1 up 4?
Yes.
And then when you go up over 2 up 8,
Yep.
over 3 up to 12, over 4 up to 16, isn't that going to create a straight line?
Yes.
So that's a constant change. It's going up 1, it's going right 1 up 4, right 1 up 4, right 1 up 4. That's a constant rate of change. Understand that? Write it because it'll be on the summative and nobody should miss it because if it's a ratio table, it has to be constant.
You give yourself.
I'm giving you the answer. Figure it out. Yes. All right. Are we on 14?
Yeah.
Last one that pretty much everybody missed. Pay attention. There are 24 girls and 18 boys in band. Okay? If you add 3 boys and 3 girls to the ratio, will the ratio be the same? Now, some of you saw the word add, and you automatically said, nope, this has to be no, and you circled either that one or that one. That's not correct. Okay? Because if you add the right amounts, you can actually create it accidentally. There are times. You guys know what I'm saying? Like if I said there were 2 boys for every 3 girls, and I said I'm going to add 2 boys and I'm going to add 3 girls, wouldn't that give you something equivalent? Okay? So let's look at this. If I did it, my new ratio would be 27 girls and 21 boys, right? Here you have 2 ratios, right? Did you guys learn in chapter 4 to see if ratios are equivalent to one another? So didn't you guys learn the big 3 methods, which were divide them, 24 divided by 18, cross product them, multiply diagonally, or simplify them? I'm just going to simplify them right now. I simplify this one. Those both have a factor of 3, correct? That's going to be 9 over 7. I'm going to simplify this one. They both have a factor of 6. That is going to be 4 over 3. Are those the same, guys? So that eliminates A and C. Right, everybody? Did everybody see how I did that? I wrote the ratio they gave me. I actually did the addition or the subtraction, whatever it's giving me. I did it, right? And then, now I just got to pick the right reasoning. So I know it's B or D. No, the ratio of girls and boys is not the same because the ratio is no longer 4 girls to 3 boys in a class. Now, if I could bring back, I can't. Oh yeah, I can. Wasn't this the initial ratio right there? When you added them, was this the new ratio? Was that though? No. That would be wrong. The D would be garbage here. Okay, it has to be letter B there. And that's not really a learning target. Again, it's more just understanding of ratios. Okay?
Pretty much.